Now I would like to invite our next panel. Our moderator is Erik Stokes from the California Energy Commission. Erik, if you could please join me on stage. And what the panel Erik is moderating is how do we decarbonize the built environment? And I'm really excited to hear from our next panelist. Erik, thank you so much. If you could just introduce yourself and let us know what your role is at the CEC, that would be terrific. And then introduce the panelists.
Yeah, happy to. So thanks, Stanley. Thanks for the introduction. Hopefully everyone can hear me. Okay, so my name is Erik Stokes. I oversee the Energy Deployment and Market Facilitation Office at the California Energy Commission. One of our primary responsibilities within the office was to develop and implement the entrepreneurial ecosystem, which Tenley and Vice Chair Scott covered in quite a bit of detail in the opening remarks today. One of our other responsibilities is really trying to overcome some of the scale-up challenges new technologies face, and we do that by trying to work with some of the downstream actors responsible for their deployment. One of the mechanisms by which we do that is by sponsoring design build competitions. So I'd like to just kind of use this time to put in a quick plug. We're going to be issuing our next design build competition in the very near term future. And this design build competition will focus on kind of your more mid-rise, mixed-use, zero-emission buildings, and buildings that aren't just zero-emission, but that can respond to what's happening on the grid and provide additional resiliency and reliability. Okay, so switching back to our panel today. So as Tenley mentioned, the focus of this is on decarbonizing the built environment. There's a lot of really interesting technology aspects to this. Building decarbonization is one of our key strategies for achieving carbon neutrality in California. And there's a number of elements, both on the energy efficiency side as well as on-site generation. Also, how do we unlock more flexibility out of these buildings to be able to respond to what's happening on the grid, as well as to be able to provide resiliency for those building tenants and those building owners as we start to see more risk, most of which is resulting from climate change impacts to the electric grid. For the most part, we have a pretty good idea around the pathway for zero emission buildings. When we're talking about new construction in the low rise residential sector, as we start to scale up towards more mid-rise, high-rise, as well as the existing building stock, we're really going to need a lot more technology innovation in this space. And I think that's a nice segue to our panelists for today. So the first person I'd like to invite on stage is Nick Brown with the Stasis Group.
Thanks so much, Erik. Yeah, I'm with the Stasis team, and what we're working on is a thermal energy storage system. It's designed for HVAC systems in commercial buildings, and it's designed to save businesses money on their utility bills. Our CalSeed grant work and Clean Tech Open, hi guys, I see some of you online today, nice to see you, have allowed our team to take it from a concept through to prototype, which you see here in the picture on the right. It's being raised into place in the supply ductwork of a union hall building in Fresno by a sheet metal union contractor there, actually. And so our team uses plant-based phase change material as the storage medium. And the PCM box is capable of storing tremendous amount of energy in a small volume, bolts into new or existing HVAC duct systems. And we've paired it with a proprietary California-made controller that manages the HVAC operations to get the most out of the thermal storage. And it works like this. In summer, businesses pay upwards of $40 per kilowatt per month based on their maximum usage that month. In SCE territory, this is based on a 4 to 9 p.m. period. And so we've focused like a laser on that period and achieved 60% or more reduction in peak kilowatts by cooling with just blowing the air over the pre-cooled box without compressor use. Now, what we plan to do with the Cal Testbed project at the UC Riverside campus is to build on our summer cooling season performance and start to extend it into spring and fall and winter. We call those shoulder seasons. That really should make the economics sing. We're currently looking for pilot sites for that effort, and we'd welcome your suggestions. And I've got to say, we feel really lucky to have been able to draw on the California Clean Tech programs like CalSeed and CalTestBed as we develop this thermal energy storage system. And CalTestBed's doing a great next step for us.
I was on mute. So thanks, Nick, for that presentation. So our next speaker panelist is Jeff Horowitz from NEXTenergy. So just waiting for Jeff to come on stage virtually.
Hello, everybody. My name is Jeff Horowitz. I'm the Director of Business Development and Partnerships at NEXTenergy Technologies. Windows, power buildings. These three simple words are really what we're all about. We make a photovoltaic transparent coating for integration into windows and glass facades to allow buildings to power themselves, helping to reduce their outsized carbon footprint and to meet emerging net zero mandates and increasingly stringent energy codes that we all know are coming down hard and fast. So Next believes that windows will need to play a key role in the decarbonization of our building stock. They're currently being underutilized, and by integrating transparent solar cells at the point of window manufacture into glass facades, we can effectively revolutionize the glass facades market and create a huge new market for on-site solar generation. Just our addressable market for commercial windows for new build and major renovation, it's a $50 billion a year market growing 5% annually. So Next is well positioned to capture a significant part of the market with its unique building energy solution. So how we do it is we coat our proprietary transparent organic photovoltaic coating directly onto glass. It's a wet coating process, which makes it a high speed, low energy process, all ambient temperature, temperature and pressure, which allows us to be very much a modular process and able to seamlessly integrate directly into factories of window manufacturers. The coatings are designed to absorb only the unwanted wavelengths of light you don't want in the building anyway, so the UV and the IR light, and we convert those wavelengths of light into electricity, allowing a chosen portion of the visible spectrum to pass through. So this is what determines the color and the visible light transmission and the other specifications of the window that a architect or the building owner would care about. We, of course, have IP around this consisting of dozens of patents, and we spun out of UC Santa Barbara's materials department, and we have exclusive license to the IP from the university for the life of the patents, and we continue to add to that IP as well. Our business model is to work closely with manufacturers of commercial windows and other architectural glazing products. Our expertise is in the material science, on the material set, and not on the whole, window supply chain. So we're not trying to reinvent the wheel, but rather enable our fabrication customers to have another high margin value-added element that they can add to their products. We have our first joint development and licensing agreement in place with a top US window fabricator. They're a equity stakeholder in our last two financing rounds. So they have a stake in our execution, and we work very closely with them on the commercialization of the technology. We've gotten to where we are today thanks to our amazing team. You see most of them here on this slide. 8 years ago, it was Corey and Daniel who spun the technology out of UC Santa Barbara, really with a great idea and some really core domain knowledge. Since then, we've grown the team to about 30 people, and we plan to add to that with key hires in the coming months as we scale to market. And we have an incredible board from architecture, renewable energy, real estate, that are giving us, really great advice and, pushing us and guiding us every step of the way. So you see here some of the next steps we're taking towards commercialization of the technology, passing some key certifications, signing up new licensees, delivering demos to early customers, and closing a round of financing that positions us to launch a first product on our first production line with our partners. We'll be working with UC Santa Barbara under the Cal test bed to do some of the chemical, optical, electronic, and physical properties analysis of our photovoltaic materials in order to establish the correlation between material quality and module performance. So that's next. I look forward to meeting a lot of you here today and throughout the course of the Cal Testbed program. Thank you.
Thanks a lot, Jeff. So moving on to our next panelist, we have Todd Gentry from Hyperborean.
Well, thank you, Eric. I am Todd Gentry, the CEO and founder of Hyperborean. What we're working on here is actually helping our customers to cut the power cord on air conditioning. We have developed a heat-powered air conditioning compressor that is operated off of strictly a source of heat rather than electricity. And so one of the first sources of heat that we're actually harnessing for operating this compressor is concentrated solar. One of the cool things about this compressor is that it can drop right into a standard air conditioning unit and replace an electrically powered air conditioning compressor. And the cooler thing yet is that it can drop in beside an electrically powered air conditioning compressor and provide free off-grid cooling when a source of heat is available, and then revert to standard electrically powered operation when it's not. And so one of the great things about using a source of heat like concentrated solar as our energy input is that we are operating during peak cooling periods. So the impact on energy savings is substantial. One of our beachhead markets is actually the mobile telecom industry. And we've chosen them because as an industry, they consume 2 to 3% of the world's power. And up to 30% of that power is actually just to cool small single room buildings that house their mission critical equipment under the antenna installations. And so this industry is looking to us to solve basically 3 sets of problems. One is it spends a lot of money on air conditioning, and it would like to overcome that. But an even bigger problem is when the power disappears at a site, all of a sudden they're running everything off of backup power supplies. And if they're having to run air conditioning off of those supplies as well, it really depletes the overall runtime. So we are helping to add resiliency to these sites by providing off-grid air conditioning during power failures. And then, of course, they're also working very hard to kind of reduce their carbon footprint and environmental impact. And we are helping with that just by cutting their electricity use. But our solution actually has a lot broader market than just the mobile telecom industry. And if you consider the number of single room buildings that need air conditioning, they're literally, the count is in the millions. And you can imagine anything from construction trailers to temporary classrooms, mobile medical clinics. So we've got a massive opportunity to provide some off-grid resiliency, cost cuttings to a variety of industries. But looking at the bigger picture, the demand for air conditioning is growing at an almost unsustainable rate. It's projected to grow by 3,000% by the end of the century. And the economic and environmental impact of that is tremendous. So we are working hard to help shave that peak demand and the cost of operating air conditioning. And another big challenge that is met by our technology is that in the electric utilities industries, there are literally trillions of dollars of generation equipment that sits idle over half the year just to be available to operate air conditioning in the summer. And so by reducing those peak demands with our technology, we can help utilities better manage that and become more efficient, which helps all of us, as well as reducing the environmental impact of power generation. We're extremely grateful to be part of the CalTestBed program. What we're actually doing with CalTestBed is working with the Western Refrigeration Efficiency Lab to kind of quantify the exact performance of our compressor and also determine how best to make it as adaptable as possible across as many different applications as possible. What we would love to do today is start some conversations about additional pilot opportunities and also some discussions with the electric utilities industries to determine what sort of deployment areas might have the biggest impact on their side and work with them potentially to optimize our pilot testing. Again, very grateful to be here. Thanks.
So moving on to our next panelist, this is a company very familiar to us. I've been working on the entrepreneurial ecosystem. They're a Cal Seed recipient as well as a Bridge recipient and now a Cal Testbed awardee. So Sergey, I'm not going to say this right, Vasileva from Lucent Optics.
Can you see?
We don't have video of you right now, Sergey, but we can hear you. There we go.
Okay.
Yeah.
Yeah. Thank you, Eric. My name is Sergey Vasilyev. I'm founder and CEO of Lucent Optics. My company is dedicated to creating impactful technology solutions that go just beyond incremental improvements in existing technologies and products. What we're primarily going after is transformational ideas that could bring new qualities, create new markets, user experiences, and also open new possibilities for making our lives more sustainable. And our main focus is improving the energy efficiency in buildings and also augmenting it with harvesting the free energy from the sun. So we have several related products, some of which are still in development and some are already commercially available. One product line is ultra thin and flexible LED lighting panels. So each panel is essentially a very uniform, low cost and highly efficient light source, which has the form of a thin and flexible sheet. So this light source can be used for making a wide variety of innovative lighting designs, which have not been possible or practical before. And what we're particularly excited about is that this technology allows for dramatically cutting the energy consumption in buildings, and yet do it through beautiful designs and with improving the overall aesthetics of the space where we live and work. So another product line is thin sheet form illuminated signage panels, which can also be flexible. And the illuminated signs that we make are up to 10 times more material and energy efficient than the traditional products in this category. And yet another product line that I would like to highlight is window films that provide enhanced solar heat control and at the same time help improve natural lighting in buildings. And this technology is the one that will be tested by the Lawrence Berkeley National Lab through the CalTestBed program. And the things that we're particularly looking for at this stage include partnering with industry stakeholders, other manufacturers and product distributors. We strongly believe in synergistic benefits of combining efforts and combining different technologies to provide complete energy efficient solutions. So we're also looking for early adopters of our products who are willing to take some potential risks in exchange for enhanced benefits that the emerging technologies like ours have to offer. And we also look for additional testbed facilities and partners for pilot and demo projects. And finally, we're also seeking opportunities for licensing our technologies to establish market players. We believe that this could significantly cut the time in which the so exciting solutions I'm talking about would become broadly available. And this is all I have for Lucent Optics. Thank you.
Thanks, Sergey. So at this time, I'd like to call up Gregory Kropsta from Blue Frontier up to the stage.
Thank you, Eric. Can you hear me okay?
Yeah, we can, Greg.
Okay, I'm Greg Kropsta, co-founder and president of Blue Frontier. This has been a really exciting news week for Blue Frontier. Yesterday, Third Derivative, a joint venture of the Rocky Mountain Institute and New Energy Nexus, announced Blue Frontier as a member of its first global cohort. We completed work on our Caltech Rocket Fund grant and started work on a new California initiative entitled TED, or Technology Early Deployment, a partnership between EPRI, the Caltech Rocket Fund, and Southern California Edison. So Blue Frontier is reducing the carbon footprint of commercial buildings by slashing air conditioning energy consumption. We address the #1 blind spot in global energy policy and greenhouse gas reduction efforts, air conditioning. We deliver comfort, sustainability, and value. So Blue Frontier was founded by 4 clean tech industry veterans in 2017 to commercialize patents it licensed from the National Renewable Energy Laboratory for an R&D 100 award-winning non-vapor compression air conditioning technology. Our product is an ultra-efficient packaged rooftop air conditioner with native energy storage. And when we say ultra-efficient, we're not kidding. Our air conditioner reduces electricity consumption by over 60%. Now, we store electricity in the form of a low-cost, non-toxic, non-flammable salt solution. The energy storage feature is critical because it allows us to consume power when it's lowest cost or cleanest. We store and shift energy to match renewable energy generation and eliminate peak electricity consumption, solving the duck curve. Importantly, we are simply better at keeping people comfortable. Blue Frontier creates a healthier and more productive environment by increasing outdoor fresh air ventilation and separately controlling both humidity and temperature. Blue Frontier's climate-friendly energy storage air conditioner brings the lowest total cost of ownership, slashes energy consumption, eliminates peak demand, the use of high global warming potential refrigerants, and materially reduces greenhouse gas emissions. So for our next steps, under grants funded by NYSERDA and your partners, the Wells Fargo IN2, the company is finalizing its design with a contract manufacturing partner. We are seeking host sites in California and New York to test and demonstrate our 5-ton units during the summer of 2021. Today, the company is wholly owned by its 4 founders, and we are seeking up to $1 million from seed series investors under the similar terms of a convertible note agreement originated by Third Derivative. We thank the Cal Testbed, New Energy Nexus, and the CEC for enabling an important dynamic test of hardware in the loop of our energy storage air conditioner that will be performed by our partner, the UC Western Cooling Efficiency Center. Thank you.
Great, thanks. Thanks for that, Greg. And so our last panelist for today is Paul Donahue with System Z.
Hello, Eric. How are you? Can you hear me?
Hey, Paul. Yeah, we can hear you.
Okay, great. Well, thank you. Thanks. Yes, I'm Paul Donahue from System Z and New World Energy, and we're excited to be part of this world's first Cal Testbed group. I'm going to show here, this is a smart meter, and although we don't make it, it's plugged into every one of the homes in most of the homes and businesses in the United States and several 100 million around the world. And we created a technology that plugs and plays immediately into the smart meter and turns any solar system into a fully functioning solar microgrid. It powers homes or buildings during public safety, power shutdowns, wildfire events, or any other grid outage. It's also universally compatible with solar and storage in the California, US, and around the world. This technology is actually proving transformative in all of our tests for all residential and building solar and batteries. In addition to delivering plug-and-play resilience for solar, it dramatically reduces the energy use and carbon footprint through a very innovative and patented energy management system that works with this in wireless and has a great many sensors. It also extends the runtime of any type of battery storage. So it doesn't really matter. Like we've been testing it with Second Life Nissan Leaf batteries and other types of batteries, from lithium ion to lithium ion phosphate and a whole host. And in each case, it extends the runtime of any size battery. And what that means is smaller, lower cost solar and battery systems can deliver 24/7 renewable energy and grid balancing services. That's the first for solar ever. Example, one of the examples is, here is one of our modules that is designed for disadvantaged communities. Plugs into the same meter, and what it does is it works with older homes and buildings where smaller electrical panels exist, and this enables them to install solar systems, battery systems, and our sophisticated energy management technology that we call the energy quarterback into any system without having to upgrade panels and do other major work or permitting or other things. Also provides first-time ability for solar homes and buildings to participate in open ADR, grid balancing, and duct curve mitigation programs. These programs pay significantly more than solar owners currently receive from net metering. So again, transforming the solar value equation for everyone and reducing the cost of solar and batteries, and then managing the energy systems that are associated with it, really transform the value equation of solar for everyone, including disadvantaged communities. And this is a major opportunity for solar to reach more and more places faster, reach the SB 100% renewable goals for California and other states. So we're grateful for the Cal Testbed program and our energy quarterback ecosystem technology, which is fully patented, is currently being installed at University of California, Irvine, the Advanced Power and Energy Lab, that I believe is also a US DOE sponsored lab for reports by world-renowned energy scientists. And we were really looking for that kind of forum rather than any of us who have a lot of experience with microgrids and renewable energy and sustainable energy. But despite that, we don't have the cachet that the University of California has. And we've been particularly fortunate to have Professor Scott Samuelson, who is a well-known energy scientist worldwide, was designated an energy champion by President Obama in 2011. And we were gratified to see that he has taken this on as the principal investigator. He was the founder of the APIP lab and the National Fuel Cell Research Lab on UCI campus. So he's a world-renowned scientist that brings enormous credibility to our technology. And so we're looking forward to that. We're grateful for the California Energy Commission and the new Energy Nexus and the Cal Testbed program for creating this opportunity for us to validate on a large and rapid scale the value and the safety and importance of our technology for solar and batteries and energy management, really. We work closely with System Z, who's begun introducing the New World Energy Quarterback technology to leading cities, CCAs, utilities, and energy program developers for adoption. And we'll be increasing our footprint into pilot programs and demonstrations with those entities and contractors as well, and large distributors to contractors. As a final piece, we've received multiple US patents on our energy quarterback technology ecosystem. Additional patents are pending in the US and 123 countries. We're excited to be part of this with the California Energy Commission and the University of California, and our growing list of partners who we'll be announcing shortly. So we're just excited to be a part of it and grateful. Thank you.
Yeah, thanks, Paul. Sounds like you guys have really hit on what's just a major pain point for so many customers, definitely in California, if not especially broader too.
Thank you. You're very kind to say so.
Yeah. So with that, I think I'd like to invite all our panelists back up onto the stage, and we'll kind of maybe switch gears towards the moderated Q&A session. Okay, I think we're just, do we have everyone on stage? Oh, there's Greg.
Yep.
There we go. Okay. So the first question I have for the panel, maybe we'll start with Nick first to kick us off, is, as it relates to building decarbonization and net zero emissions, what do you see as a barrier related to rapid tech adoption in buildings? And just kind of the second part of that question, how do you see your time at Cal Testbed maybe helping address some of these barriers? So Nick, maybe you can kind of kick us off.
Yeah, barrier is building a network as a small entrepreneurial venture, maybe coming out of a university or something with a good idea. But even if you don't need a whole lot of seed funding, you need a network and you need partners to build that with. And CalSeed and Clean Tech Open have, and now Cal Testbed are really helping us build that network. We're also learning through contact with utilities and others about M&V and the importance of that in demonstrating your technology works and quantifying the savings and eventually qualifying for incentive programs. So it's really helped us incubate as it was intended to do.
Yeah, same question. Jeff, maybe if you have any thoughts on that question.
Yeah, I do. I think one of the barriers, and from our perspective, is the gulf that exists between the building and the solar sectors. Where, unlike traditional solar energy generation, rooftop generation, architectural solar generation, it's quite a bit more complex, and it depends on the cooperation and the collaboration of numerous stakeholders. Its success relies on buy-in from building owners, architects, construction companies, glaziers, building envelope suppliers, civil, electrical, like engineering firms. So, until recently, there has been no supply chain to really support, building integrated photovoltaics, on the facade of a building, for example. There's been boutique BIPV suppliers, but none significant enough to really be embraced by the mainstream, construction market sufficiently, to create a real market. So, we're trying to address that by working, with the industry, especially, the handoff of the window unit from the fabrication step in the supply chain to the glazing and the framing step of the supply chain is really important to us. So we're working with the top glazing firms in the United States to kind of build a better mousetrap, if you will, of their framing systems that handles the wires that are needed, and really working with the industry all across the supply chain to really integrate two supply chains. At the end of the day, we're combining the window and the energy subsystems of a building, so you really need to integrate the supply chains to do that. So, we feel like, the Cal Testbed will allow us to meet, other players in the market that, want to address that challenge.
Great, thanks. Todd, same question. What barriers do you see, especially when you're trying to get traction in the building market, and kind of what value do you see from your kind of participation in Cal Testbed and really trying to address some of those barriers?
Well, at the end of the day, a lot of what we are doing is working with very large entities initially in our target market. So they are laser focused on, does this make sense financially? And a big portion of their decision-making process is driven on what's the payback period from the savings of any technologies that we add, what's the environmental impact, and so we have to be able to quantify those clearly and accurately in order for decisions to be made that push the technology forward as a deployable option for them. So that's one of the things that we're particularly excited about the Cal Testbed program bringing to the forefront, is kind of some independent validation of the numbers in a lab setting, and that's a perfect launching point for us to jump out and start gathering the data in the field to really kind of support payback periods, carbon reduction, and what sort of impact we have. So this is extremely helpful.
Great. And Paul, kind of turn to you. You kind of touched upon this briefly in your presentation, really kind of the value of having, kind of a well-respected organization such as UC Irvine kind of not put their stamp of approval, but at least give some sort of, certification to what you're developing and the value when you're trying to interact with potential customers. Can you expand a little bit upon that?
Yes, thank you, Eric. A great question. So here really says I've been a serial entrepreneur after I left the corporate world in 1990. And so I've been through this a few times, and we're particularly fortunate and gratified on a.
So it's really about, understanding their needs, building, their trust, positioning our company as an honest authority for, this nascent technology and BIPV in general, and making it easy for them to specify. So that's, proving out the technology and rolling it out into real world sites and, installations where we can provide data that's meaningful for them to, become the early adopters.
Yeah. And Todd, so when we were kind of conceptualizing Cal Testbed, I think one of the objectives we were really after is how do we kind of streamline from that prototype into pilot demonstrations, field trials with customers, for you and your organization, who are some of those early customers?
Initially for us, we are focused on the utilities industries as well as mobile telecom and rail. We've had initial conversations with key partners in all of these, and as you pointed out, it's really about the pilot testing and gathering of the data. So we have 10 pilots that are scheduled to deploy in 2021, and the testing with Cal Testbed will be kind of concurrent to all that. So towards the end of 2021, we should have a really helpful bit of data that we can then leverage to begin the scaling and the commercialization.
Great, thanks. So we're almost at time, so I want to make sure we get to our panels first with those last questions. So Nick, can you talk a little bit about who some of your target customers are, and especially who might be some of the first pilot demonstrations you'd want to target with your product?
Yeah, and we have a similar initial focus to Greg at Blue Frontier. Greg, we should talk. But we are looking for the buildings that we're going to perform best are those with finite cooling loads in summer especially. And so when we're going to get our best peak reduction when we can size our thermal energy storage system to their operation characteristics. So that could be banks. It could certainly be small office buildings. But we've chosen that target both because there's tons of them, as Greg's correctly said, but also because they're likely to be located in disadvantaged communities. And I really applaud all these programs for that focus. We've taken it to heart. We know it's the right thing to do, both for our business and for responsible use of ratepayer money. So we've really built that into our business. And when we started out in Modesto, which, a lot of that community is disadvantaged. And when we set up in Southern California, we again looked for facilities that were those types of communities and chose to locate in Pomona, Corona, partly as a result.
Paul, same question. And I think you hit on it a little bit in your earlier remarks, but who are some of the initial target customers you're looking for?
Well, thank you. Yeah, ours are very targeted. They're anyone who currently owns a solar system or wants one, because we add tremendous value and reduce the cost. So that's a pretty good value equation. Now, how do you reach them? They're reached by contractors who sold their systems initially and install and maintain them. So that's one avenue, and we've chosen a distribution partner who, again, is a very large distributor to contractors. And so they're on the call. They're watching us very closely. They'll show up at the University of California to interview the professors. That's another advantage we really didn't talk about, is we can invite folks in before the report's finished to sort of dialogue with experts. It's an incredible thing. So the other avenue, System Z, of course, is very active with Richard Shorsky, who is part of ZNE Alliance, and you know him, CEC. And Richard and his team, Sam Irvine and others, are leading an initiative to CCAs and utilities and cities where they have demand response programs and load management and reserve adequacy programs that are completely untapped to date by solar, and they're opening this up. So very cool. We're so delighted to have partners, and thank you for asking.
Yeah, Paul, I think a lot of customers with PV were surprised when utilities started issuing PSPSs that they would lose their power in the event of a PSPS. Is that a kind of a market you guys are looking at some point down the road?
Yeah, you hit the nail on the head. Almost all solar installed anywhere in the world is what's called grid tied. And so what happens is, if you see this as the grid up here in your house and then your business or whatever, and solar, it feeds in, and what it does is it contributes, or it is a deficit and allows always interact. So when the grid goes down, solar goes down. It has to within, I forget how many hundreds of a microsecond. It's instant. And so the solar panels are still producing energy, but the inverters are shut off and they can't send the power through because it might backfeed to the grid and harm a worker. And so when we designed this, what we did is we put all of the software and hardware to sense what's happening and automatically switch things. And then there's in it is a patented thing called the public safety interlock, which prevents backfeeding of the grid. It won't turn the inverters on until that says this has switched, the relay hasn't hung up, it's in perfect condition. So it has its own fault detection already built in. Anyway, I'm promoting too much and I apologize. But yeah, people were sold a bill of goods when they bought their solar. They were told we're going to stick it to the man and we're going to, all untrue, right?
Yeah.
So thank you for asking.
Yeah, thanks, Paul. And Sergey, kind of talk maybe, with some of you have a number of kind of emerging technology products. Who are some of the early target customers for those products? Oh, Sergey, I think you're on mute.
Sorry about that. Yeah, for our lighting panels, we decided to try not to compete head-to-head with the established industry players. So we decided to go after like a low-hanging fruit and to the our pilot market, which is going to be a highly customized signage, illuminated signs, and this is a highly fragmented market. So there are really no players like you can find dominating the lighting segment. So, and our customers in this segment can be just end users, not only the established manufacturers. And we're happy about this opportunity because it will allow us to target a wide variety of different applications, test our technology in different highly customized solutions, which we could not even imagine ourselves. And I think that this will be very beneficial for the next stage where we'll move to the next level of offering our products on a large scale for the lighting applications.
Great. Thanks, Sergey. And I see Tinley, so I think she's here to tell us our time's up. So thank you to all our panelists today.
This amazing conversation, but I want to keep us on schedule as best as possible. And I just wanted to thank you, Erik, for being such an excellent moderator and gentlemen, for your wonderful comments and for presenting your amazing innovations. I'm really excited as the director of the Cal Testbed program to learn more and to see your faces and to get to know more about how our program can help you accelerate towards commercialization. So I want to thank you all very, very much. And our